Hello F Sharp, how are you doing? Today what I want to do is introduce you to F Sharp records. Now this is the first more complex type that you would start using in F Sharp. Now after you learn about the integer types and strings, now you want to start creating types that are combinations of those things. You want to start putting them together. So how would we go about defining records in F Sharp? Well, let me show you. So first what I would do is I would use the word type to indicate, hey, I'm defining a new type now. And I always use chicken as my default type for examples. And then I use the equal sign. Now, then I'm going to do a return, tab in, and use curly braces. And it's inside of these curly braces that I'm going to give the fields that are in my record and the types associated with that field. And so often what I'll have is a name, and I'm going to say it's a type string. And I'm going to have a size, and I'm going to say it's a type float. And so now I have defined a simple record in F Sharp, the humble chicken. Now, if I wanted to create an instance of chicken, I can use a few different, I'll use a simple record creation syntax. So let C1, and then I'm going to say curly brace, name equal to Clucky, and then a semicolon, and then size equal to 10.0. Now, what's cool is that with F Sharp is very smart about looking at, hey, you're clearly trying to create an instance of a record. And what it's going to do is it's going to look up essentially, because the compiler is always kind of, the way the F Sharp compiler works is it starts top to bottom. And then when it needs to do type inference, it looks from where you're coding and then essentially goes straight up. There are exceptions to that when there's recursion involved, but generally it's just looking up to find the type that you're talking about. So what the F Sharp compiler is doing is it's saying, okay, I see that you're trying to create an instance of a record, and the record you're creating has a field of name as a type string and a field of size with a type of float. And when I look up, this is what I find. So it's saying like, oh, clearly you're creating a chicken because the shape of this looks like a chicken. Now, what would happen if I defined turkey? Again, I'm using the keyword type to indicate that I'm defining a type now. I give the name of the type that I'm defining, the equal sign, and then curly braces on new lines. And here I'm going to say, hey, name, string, size, float. Now, what we can see is that the compiler is saying, like, oh, C1 is actually a turkey. And let's go ahead and hover over it. Is the compiler thinks like, oh, you're making a turkey. And the reason it thinks I'm making a turkey is because, again, it's looking at name, it's looking at size, and it's going up. And the first thing it finds that looks like that is a turkey and not the chicken. So what if we really want to create an instance of a chicken, though, after all these type declarations? Like, you could do something like this, but that's kind of silly and obnoxious, because often what happens is you define a bunch of types in one file and then you start working with the types in another file. So just moving this instance declaration is nonsensical. So there needs to be a way to resolve this conflict, right? Well, there's a few different ways that we can do it. One is we could prepend this first field with the type that we're wanting to create. In this case, I did turkey but it's already turkey. So like, no, what we really want to do is chicken. And so what this is now telling the compiler is saying, hey, I am wanting to create an instance of chicken here. And so by prepending the name field with the type that I'm wanting to use, I'm now guiding the compiler, and the compiler is like, oh, clearly you're wanting to create an instance of chicken here. That's one approach that we could use. That's actually not my recommended approach, but it's the first one I learned. So that's why I brought it up first. Another way you could do it, let's delete that, is we could actually put that type hint out here. Oh, Got to be able to spell correctly for it to work though. So now what we're doing is just saying, hey, I have a let binding, so I am declaring a binding. I have the name C1 and I want to bind that value to something. Before, when this wasn't here, the compiler was trying to figure out what it is that I was trying to bind to and just kind of using TypeInference to just do it for me. When I do this though, when I'm now telling the compiler saying like, okay, let, so the compiler knows, okay, I am declaring a binding. Let's bind the name C1 to something that is of type chicken. So here I'm telling the compiler ahead of time, like the thing to the right of this equal sign is going to be a chicken. That's what this colon and then chicken is telling the compiler. So when we put this in here, we're now telling the compiler what we expect to be on the other side of that equal sign. And so now what the compiler does when it looks at this, it's not trying to figure out, oh, what does this look like? It says like, this thing better look like a chicken because you told me it's going to be a chicken. And so what happens now when we add a field, let's say color string. Well, now what's happening is that the compiler is complaining and saying like, hey, you've not given an assignment for the field color of type records.chicken. Records is the file name that I'm in right now. And so it's like, hey, I'm really expecting you to give me a color here. There's a problem. Now, if I remove this, it's going back to think that this is a turkey. And if I move chicken down below turkey, the compiler, now let's think about what the compiler's thinking now. Let me get rid of this line so we still get it all on here. I'm just going to zoom out a little bit. Compiler saying, okay, I am binding the name C1 to something. I don't know what it is yet. Okay, it's got a name. Now, normally it would go to chicken, but it also sees the signs like, okay, it's still kind of looking like a chicken, but there's nothing else. There's nothing else now. And so the compiler's like, well, chicken's a bust because this record declaration does not have a color field and chicken has color. So I'm going to keep going up to see what I find. And then what it finds is turkey. So it knows by the structure of this record declaration that, hey, this must be a turkey. Again, we could also put a hint in here saying like, hey, this is definitely a turkey. There are situations where you might have a lot of types with matching fields. That is entirely possible because, like, I mean, for example, here we have turkey, we have chicken, we could have geese, we could have all kinds of different birds on our farm, and they all have a name and a size for some reason. And we want those all to be distinct types because we're trying to do some kind of domain modeling representation to keep them very distinct so it's easy to keep track of. And so sometimes we will need to give the compiler some help to say like, hey, this is really what I was intending here when I created this. And so using this syntax, using this hint is a really great way to tell the compiler like, hey, I'm anticipating that the thing to the right of this equal sign is going to match the shape of this type. It should evaluate to this turkey. So that's one syntax for creating an instance of a record. Let's talk about some other things that we can do. So I'm going to go ahead and move this up and comment it out. I really don't care about it right now. And that was one way of creating an instance of a record. And it's very common. Now, in real world scenarios, you may want to have some validation when you create an instance of a record because, for example, strings can be null, right? They can be empty strings. And when we have a chicken and we give it a name, we want that to mean something. And we would really like to have that sanitized. Now, I'm not going to go nuts here. Like we could say like, hey, we're going to declare type name. And so like type name is equal to name of string. Like I'm not going to go nuts like that. So let's just say this is the representation that we wanted to work with. This was good enough for us. What are some easy ways that we could add some validation to this to make it easy for us to create an instance of a chicken and make it very ergonomic to work with. There's kind of two different approaches that I have found to be great. Often what will happen is you'll have the type chicken, and then right below it, you'll have a module also called chicken. And the module will be a place to put all the code for working with chickens, right? So if you like want to rename a chicken or grow a chicken, or like whatever thing you want to do with chickens, the functions for doing that would be here. And what I often do is I often define a create function. Okay, let create name size equal. And what I'm going to do is say like, hey, name is equal to name, size is equal to size. And what this function is doing is it's saying, hey, I have a function. Its name is create. It takes two different parameters. One is name, one is size, and then is going to return this record. Now, again, F# type inference is doing a lot of heavy lifting for us, making this really convenient and easy to use. Because let's think about what the compiler is actually doing here. It's saying like, okay, I'm coming through. I realize I'm defining a function here. It has two parameters. One is name, one is size. And now I'm creating an instance of a record. That record has a field called name that is a string, and it also has another field called size that is a float. It then looks up to see what could match that and say, hey, that looks like chicken. Actually, I'm going to slightly correct what I just said. It's looking for a record that has the field name and the field size. It doesn't know the types yet. Like when the compiler is coming down and looking at this code, and we're thinking like the compiler. I come down, I see you're creating an instance of a record. That record has a name field and a size field. I don't know what the types of name and size are though. So what the compiler does is it now goes up. It's going up, and it finds a record, chicken, which has those same field names, name and size, saying, oh, this must be the type that you are wanting to create here. And if that's the type you're wanting to create here, then I know that name is a string and size is a string. Therefore, the parameters you're passing into this function must be a string and a float. So this is type inference doing a ton of heavy work for us by like just looking at the context and saying like, oh, these are the types. So this is how F# gets the feel of a dynamically typed language while actually being very statically typed. Trust me, it is statically typed. And like if we wanted to, we could put additional information here, right? So you could do something like this where you're saying like, hey, I could say like, hey, name in this case is a string. So this is how I would do that. So like I have this parameter for this function. The parameter's name is name. It is a value string. And I have a parameter size as a value float. Like I could do that. And I could even say, hey, this function returns a chicken. So this is me doing all the work for the compiler, right? So I'm like, I'm telling it, hey, name is a string. I'm telling it size is a float. And I'm telling it, again, this function is going to return a chicken. So this is the syntax for when you say like, hey, I want to tell the compiler what I expect the return type to be. You almost never need to do this because the compiler can figure that all out. It can figure that all out from context. In some cases, when I'm writing really complex code and I find this kind of thing necessary, but if you're starting out, it's going to be a while before you get there. So don't worry about it. But I just wanted to let you know, like, that's a lot of things that I did not have to type. And this is far fewer symbols, much less words, but it's still just as statically typed, just as fast, just as robust of code. So this is great. So this is one example of what you would do. And so then when you say like, hey, let's see 2 equal chicken create, I'm going to say clucky 2, and now the size is 20. The bird has grown. So now I'm creating instances of chicken using this create function. Now, that is one approach. Another thing that you could do, another way of doing this, so, and to be clear, this is by far the most common approach that I use. I'm going to show you another approach and then I'll tell you like why you might be interested in it. But if this is your default, you will be in a very happy place and write some very clean, elegant F# code. Another way to do it is to add a static member to chicken. And I'm going to say have this be create, and it's going to take name, it is going to take size, and again, it is going to say name equals name, size equals size. Okay, what is this? Static member is I'm adding a static method to this type chicken. And really behind the scenes, this is a class. So this would be a C# class. If you're wondering like what it turns into at the end of the day, it turns into the same thing that a C# class would turn into. We're adding a static member to it, same as a static method. This is the name of that method, and these are the parameters that we're giving to it, name and size. And it's a single thing that we're sending to it. In this case, it's a 2-element tuple. And again, we are returning a chicken. And again, it's figuring out that like, hey, you're creating a chicken just by the context. It's like, hey, what matches this shape? Oh, it's literally right above me. This must be a chicken. Again, I can C2 is equal to chicken.create. Now it's going to look a different clucky 3. And this is an even bigger chicken. Because why not? Oh, 30. I want this to be an outrageously large chicken. So you might look at this and say, like, Matthew, that's really similar. Why do I care about that? Well, it's a great question. This is a function. Then there's a lot of things that you can do with functions that you can't do with methods. And I'll have to do another video about that, talking about those kind of complexities. But if you came to F#, you're probably excited about the functional stuff, so you might already know. Why would I do something like this? Well, the reason I would do something like this is because I can overload methods. So let's say, like, you know what? I want another static member, create, and I'm just going to give it a name. And now when I create that chicken, name is going to be equal to name, but size is going to default to some value. And this is not going to conflict. I can also create a chicken using that syntax. So let's see, 3 equal chicken create, and then clucky 4. And now this is using the other method for creating an instance of chicken, and it's just giving us a default size in this case. So static members are really useful when you want to define methods for creating records and you want to be able to overload those. You could also use default members. I've actually not default parameters, optional parameters. Sorry, I've never actually used optional parameters, so I can't really testify to whether that they're great, whether they're bad. I just haven't used them. I've always used this technique if I really needed to. So that's another way of creating an instance of your record. And if you want, now what you can do is you can add some type of validation logic here. So you say like, hey, validation logic here to say like, hey, size, if size is less than or equal to 0.0, then invalid arg name of size cannot have negative size chicken. That would be horrific and bizarre. Who knows what's going on? So in theory, you can have, well, not in theory. In actuality, what you could do is you could insert logic here to do some domain validation to say like, hey, do the input values make sense? Are the strings non-null? Are they non-empty? Things like that. So hopefully that's helpful to kind of give you some context about being able how to define records in F# and different ways for creating them and working with them. I hope you found this useful. If any of this was confusing, please let me know in the comments. If there's things that you want me to dive deeper into, I would love to hear it. Next time, what I'm hoping to do is talk about structs and working with structs in F# because they are really critical when it comes to writing fast code, We don't always want to allocate on the heap. Sometimes we want to allocate on the stack. And so that's what we will be talking about next time. Thank you very much. You have a wonderful day.